So we're going to continue our discussion in chapter 9, which deals with significance testing. We're actually going to discuss creating and running the significance test, first focusing on a significance test for a proportion. So you'll notice there's a lot of kind of similarities and overlap between what we're doing now and what we did in the last chapter. A significance test is often run at the end of any type of research study or an experiment. And what we're trying to do is we create these hypotheses like we saw. We have the null hypothesis and the alternative, and then we run this significance test. So similar to what we saw in terms of confidence intervals, we have conditions that we need to check. And you'll notice they look very similar, almost the same as what we saw in the last chapter for proportions. So condition 1 is that random sample or random assignment condition, depending on whether or not we're dealing with a random selection, a random sample, or we're dealing with an experiment when there would be random assignment. Your second condition, your normality condition, which in this case is your large counts condition. Notice we're back to n times p. When we dealt with confidence intervals, it was p hat because there was no p to use. When we're dealing with a significance test, we're going to be using p, which is the value from your null hypothesis. So for example, say you think that the proportion is less than 50%. Your null is 0.5, p equal to 0.5, alternative p is less than 0.5. Maybe your p hat is 0.47. You're not going to use 0.47 here. You're going to use that value of 0.5 that's in your null hypothesis. So np greater than or equal to 10 and n times 1 minus p greater than or equal to 10. And we still have our same independence condition that your sample size has to be less than 10% of the population size, only when we're dealing with those cases that involve random sampling. So when we're dealing with these types of problems, we're going to be finding what's called a test statistic. What a test statistic measures is how far the sample result, in this case p hat, is from the null parameter and in what direction on a standardized scale, aka a z-score. So we're getting back into that idea of z-scores here when we're talking about the test statistic. The formula for the test statistic, or z, is on the formula sheet. If we go, it's right here, standardized test statistic minus parameter divided by the standard error of the statistic, standard deviation of the statistic, same thing, okay? So that formula is on the formula sheet. And again, what that is measuring is how far away your sample statistic is from the hypothesized null value. So what are the 4 steps? Well, I think like we saw in confidence intervals, a good way to think about this is to go through that state, plan, do, and conclude. It organizes things in a nice way for somebody grading the exam as well as for you actually doing the example out. So the state phase of that is stating your hypotheses. Stating your null hypothesis, stating your alternative hypothesis with the proper notation, as well as defining the parameter and noting the significance level. Remember, for these proportion problems, our hypotheses will always be based off of p. Next step is to plan. In your plan, you should name the test. The test that we're going to be carrying out in this section is a 1 proportion z test. In addition, you need to check the conditions. That's checking those 3 conditions that we just saw up above. Third thing, you're going to calculate the test statistic and find the p-value. I'm going to show you how to do it by hand. I'm also going to show you how to use the calculator to do it. My personal recommendation is to use the calculator. I think it makes your life a little bit easier. So I'm going to recommend that you use the calculator when you're doing these examples. Final step is to conclude. In your conclusion, you want to link the p-value to the significance level, state whether you're going to reject or fail to reject the null hypothesis, and then write your conclusion in context. Your formula for your test statistic by hand, which might be useful for a multiple choice question, is z is equal to your statistic, which in this case is p hat, minus your parameter, which is your hypothesized value for p, divided by the standard deviation of the statistic. And notice that we're using p sub 0, meaning your hypothesized value and your null hypothesis, not your p hat, in the formula for the standard error. That'll get you your z or your test statistic. In cases where your sample data does not support your alternative hypothesis at all, there's no reason to run the test. So for example, maybe you hypothesize that the actual proportion of whatever is greater than 0.5. That's your alternative. You go out, you get your sample data, and it's 0.31. There's no reason to run the test because there's no way you're going to be able to prove that the actual proportion is greater than 0.5 if the sample proportion is only greater than 0.31. So in this case here, there's no reason to actually run the test. You would only run the test if your sample proportion is actually greater than 0.5, and then you want to see, okay, do I have strong enough evidence to then prove whatever I'm trying to prove? The next 2 pages are examples which I want to go through in class because I think it's important to spend a lot of time going through this so you understand the steps that are needed to include, as well as actually answering the questions. So we're going to skip actually pages 7, 8, and 9 and jump to page number 10 in our notes. And we're going to do plenty of examples of significance tests, both in the notes as well as our own examples. So let's head to page 10. Hopefully we'll head to page 10. Oh, there we go. And page 10 discusses a bit of a difficult topic to grasp an understanding of. We've talked about type 2 errors, and now we're going to add this concept of power into that. So remember, back to type 2 errors. Type 2 errors are when we failed to. Type 2 failed to. So we failed to reject the null hypothesis when we really should have rejected it. Before we get into that, I want to just mention that we can run these tests on the calculator by going to a one-prop z-test. So if we go on our calculator, similar to confidence intervals, if you don't want to do these things by hand, you can go over to tests and down to number 5, and number 5 is a one-prop z-test. It's going to ask you for p sub 0, which is your hypothesized value, your x, and your n, as well as the sign in your alternative hypothesis. Then you can hit calculate or draw, and you would get results. So for example, maybe we want to try to prove this, that it's greater than 0.5. Maybe in our sample, we got 85 over 150. I'm trying to prove greater than. You can either draw, in which case you would see the normal curve, or calculate, and you would get your z, your test statistic, which we saw the formula for before, as well as your p-value. So you can use a calculator to do this, but again, we'll look more at that actually in class. Moving on to power. So what is the power of a test? So the power, you can think of it in several different ways, which I've defined here. Power is the probability of avoiding a type 2 error. Or, in other words, the probability of making a correct decision when HA is true. Or perhaps the simplest way to think of it is the probability that you correctly actually reject the null hypothesis, given that the alternative is true. So it's really a conditional probability where you're saying, okay, given that the alternative is actually true, what's the probability that you're going to correctly or that you're going to actually reject the null hypothesis? That's how power is defined. You will never be asked to calculate power, but what power is it's 1 minus the probability of a type 2 error. A type 2 error is defined as beta. Remember, type 1 error probability is just equal to alpha, which is your significance level. Type 2 probability is equal to beta, and power is equal to 1 minus beta, or 1 minus the probability of a type 2 error. And again, this is how you want to think of what power is. We're going to look at this example in class, so we're not going to spend any time on that. I just want to lay the foundation for what power is. Let's look at part D, though. Are there anything else that affects the power? Okay. There are several things that can affect the powers, which we're going to see down below. Other sources of variability may affect the power, okay? So the good use of control, blocking, stratifying, all of those things could affect the power, okay? It helps to reduce outside sources of variability, which in turn is going to increase the power. And there are 2 ways to increase the power, which we're going to see as we go through this. And those 2 ways of increasing the power are to increase the sample size and to increase the significance level. And again, there's going to be lots of examples that we're going to go through in class. It's a very important lesson, so we're going to spend some time on this. So it'll probably cover at least 2 days to go through all of this. But I wanted you to lay the foundation first, especially with A, how do we run a significance test? And B, what does it tell us? And again, at the end of every significance test, or during any significance test, as we saw in here, you're going to have that null hypothesis. You're going to have that alternative hypothesis. And now what we're going to be getting is, how do we actually find this p-value? And what do we use with that p-value in order to make our conclusion like we practiced in the previous lesson? So we'll see lots of examples. I'll see you in class. Have a nice day.